Hello and welcome back to College Algebra, MAT 150. In this lecture we're going to be discussing the basics of logarithms. So what is a logarithm? Well, in the last section we talked about exponentials, but we can say, we can at least put everything in context for these terms. If we have an exponential function, we have g of x equals log base b of x. So b is the base, and it has to be greater than 0 and not 1, just like the base of an exponential. That's not a coincidence. And it's defined, as it turns out, to be the inverse of the function f of x equals b to the x. So logarithms are inverses to exponentials. This is to say that when we compose them, so f inverse of f is like, remember that's like plugging f of x into this, gives you x. And when you look at it like this says when you log an exponential, what you get out is the exponent. Namely, the output of the logarithm is an exponent. You can compose them the other way as well, and b to the log base b is also x. But more importantly, from the first one that we looked at, this one, f inverse composed with f, we observed basically the output was originally an exponent. Again, this means that what we call the output of logarithms is an exponent. Okay, and then notice that for here we have a base, so we have to have a base to define a logarithm, otherwise it doesn't make sense. And that base is always equivalent to the base of an exponent. All right. Because exponential and logarithmic functions are inverses, what we can do is then talk about equivalent equations, okay, between one logarithm and one exponential function, and because they are inverses. And if we do this, this will help us sometimes understand what logarithms actually say. So if you're trying to look at log base 10 to the 100, and it equals 2, as it turns out, a way to understand this problem is to say, hey, this base, and then we have an output of 2 for a logarithm. We should think about that as an exponent. And if that's a base exponent, 10 squared equals 100. So this 10 squared equals 100 is the equivalent equation that we're looking for. All right, so if we look at number 2, same thing. We have log with a base of 3 of 81 equals 4. The output is the exponent. This, the base is the base of the exponent. So base with output with exponent is 81. And this makes sense. So 10 squared is 10 times 10, which was 100. 3 to the 4th is 3 times 3 times 3 times 3, which is in fact 81. All right. So now, if we're looking at things from the exponential side, what is an equivalent equation? Well, we have 5 to the 3rd power equals 125. Well, remember, for logarithms, we have to talk about a base. What's the base here? The base is 5. What is the output of a logarithm? It's an exponent, so that must be 3. So what goes on the inside is the 125. This is the equivalent equation. And what's the equivalent equation for this one? Again, 8 to the negative 2 equals 1 over 64, which is a true statement. Again, you could multiply 5 times itself 3 times. You could, again, reciprocate 8, so you have 1 over 8 squared to get rid of the negative exponent. 8 times 8 is 64, 1 over 64. True statement. So what is the equivalent logarithmic statement here? Well, log, again, what's the base? Because we need bases for our logarithm. The base is 8. What's the output of a logarithm? It's the exponent, which in this case is negative 2. And the input for the logarithm is the output of the exponential. Again, because those swap for inverses. All right, that concludes everything from this lecture.